Example 2a, a rectangle has its base on the x-axis. Okay, so let's draw a coordinate plane. Are you ready? Okay, it's base on the x-axis. So it looks like I'm gonna have some base here. So a rectangle base on the x-axis, and its upper two vertices on the parabola. Oh man, let's graph that out. So this is y equals negative x squared plus 12. You're going to have a vertex at 0, 12. So let me, do I need 12 tick marks? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. I'm sketching out our parabola for now. I also need to find the x-intercept. So x-intercept is when y equals to 0. So an x squared equals 12 square root of 12. Square root of 12 is in between 9 and 16. So square root of 9 is 3 and square root of 16 is going to be 4. So I just need 4 tick marks. 1, 2, 3, 4. 1, 2, 3, 4. All right. Square root of 12. In between that, this is square root of 12. This is square root of negative 12. And then vertex up here. This is the parabola. All right, then it says we have a rectangle, okay? The base is on the x-axis and two vertices on the parabola. So one vertex, two vertex. If it's a rectangle, remember, it has the sides gotta be parallel. So this is your rectangle right there. And guys, this right here, technically you can draw this rectangle however you want. Would you agree that this is an okay rectangle as well? Or would you agree that this is also an okay rectangle to have? As long as you meet those requirements. Okay, so right now I'm going to stick with my purple. Oh, come on, dude. Don't erase my beautiful drawing. Oh, all right. Oh, come on. Okay, so I'm sticking with my purple drawing. What is the largest area of the rectangle and dimension? So very similar to example 1. I'm going to do the same way. Okay, so area is going to be base times height, which is going to be, well, let's look at the base really quickly, y'all. Let's see. Let me sketch this again. Okay, so the base is here. So if I were to label this point, students, this is going to be unknown x, right? Comma, unknown y. Well, if that's the case, then this is going to be 2x. So the base is going to be 2x. And the height is one unknown y. So that's your area formula. Well, we cannot have one equation with two variables. So just like earlier, we are going to rewrite it with respect to x. So 2x times y is this. So that's what we are going to substitute in. 12 minus x squared. And then from here, looks like, honestly, guys, this one looks easier to distribute and then use a power rule. So that's going to be 24x minus 2x to the third. See? So take the derivative and see if we can find absolute max. Okay, that's 24 minus 6x squared. Let's find critical points. So set equal to 0. 24 equals 6x squared. Divide both sides by 6. So I'm going to get 4 equals x squared. Take the square root. Normally, like I said, we would do plus or minus, but because we are looking for dimensions, we are going to stick with the positive 2. So 1x, students, is positive 2. But remember, this base is 2x. So right now, we have a base. I'm going to move over really quickly. So your base right now is 2x, which is 4 units, okay? Okay, so now your height, I'm going to plug in 12 minus 2 squared. So that's 12 minus 4, so 8 units. So right now your height is 8 units. So that means your area is 4 times 8, right? Base times height. So area is going to be 32 units square. All right, so let's write a complete sentence with all of that in there. the largest. Area is 32 units square with dimensions of 4 units by 8 units. Okay, box that up. Okay, to be said, a right triangle has one vertex on the graph of y equals 9 minus x squared. So you know what? Normally when I see these, I write them in order and I graph them out. So I'm going to move this down. Okay, so the vertex is 0, 9. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I need to find x-intercept. So y equals to 0. And then that's x squared equals 9, x equals plus or minus 3. So x-intercept, we're not dealing with lengths yet. I'm just sketching out the parabola here so I can draw my triangle. Okay, so that's the curve. So the triangle has one vertex on that parabola, but the x has got to be positive at some random point x comma y. All right, so positive x means I'm in quadrant 1. So this is x comma y. Okay, another at the origin and a third on positive x-axis. Well, since it is a right triangle, and again, it's not on 2. Okay, this is just randomly drawn. Okay, so right triangle like that. So that is positive x comma 0. Beautiful. All right, guys. So what is the largest area? Perfect. So we are going to look for area equals 1/2 base times height. Here is your base, which is an x, and here's your y, which is your height. So area equals 1/2, base is x, height is y. And just like all other previous questions, right? We can't have two variables, so we have to take out one of the variables and substitute with something we come up with or something that's already given to us. Since y is already given to us, it's easier to substitute y with 9 minus x squared. Now we are going to, for me anyway, you can use product rule, but for me, I'm just going to FOIL this out and then use power rule. So that's going to be 9 over 2x minus 1/2 x to the third. Okay, so the derivative, the reason we need the derivative is so we can find the absolute min and absolute max. So 3 over 2x squared. Let's find the critical points. So 9 over 2 equals 3 over 2x squared. Let's get rid of 3 over 2 by multiplying 2 over 3. 2 over 3. Cancel, 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 cancel. 9 divided by 3 is going to be 3. So I'm going to move it here. So 3 equals x squared, x equals 2. And again, if this is not an application, you would need plus or minus, but x represents the base. Oh yeah, cool, I got base. All right. The height represents its y, so it's going to be 9 minus rad 3 quantity squared, so that's 6. So this is your height. Okay, so now we are going to plug it in to get the area. Area is 1/2 base times height, which is 1/2. Base is rad 3, height is 6, so that's going to be 3 rad 3. All right, so we have everything we need. Let's write a complete sentence. The largest area is 3 rad 3 unit square with dimensions of rad 3 units by 6 units. Okay, box it up. All right, guys, so to help you guys solve these optimization problems successfully, these are some strategies for solving your maximum or minimum problem. Okay, so number one, understand the problem. What does that mean? That means read it once. If you don't know what it's asking, read it again. So read and read it again. Identify what you have and what you are looking for. Okay, I normally underline these things, okay? Now, number 2, you guys see me do a lot of drawing, right? So draw a picture. Okay. Label all parts using variables or use what they gave you. Then number 3, graph the given function. As you saw, I was always graphing out the parabola. Graph the given function and find the applicable domain or sometimes range, and find the applicable domain or range. Remember, in an application, you can't always have the answer that you've solved for. You have to go back and make sure it fits, all right? 4, identified the critical points and endpoints if needed, okay? Then number 5, solve the problem. But in an application problem, you got to go back and check your result to see if it's within your restricted domain, okay? Check your result to see if it's applicable, okay? If this is a homework question, you may even check it with your, maybe check with graphing calculator or Desmos. Only if this is your homework, okay? Now, number 6, interpret your solution. Using complete sentences, okay? Now, when you guys write your sentence or sentences, make sure it makes sense, all right, guys? Make sure it makes sense. How about that? Make sure it makes sense. All right.